Now, physical equilibrium, physical reactions, those reactions in which the change in only and only physical states of the substance takes place without any chemical change. Ice water system, melting of ice, ice solid plus heat, equilibrium, water, less volume, more volume. It is an endothermic process and there is a decrease in volume. Thus, the favorable conditions for melting of ice are high temperature and high pressure. Water vapor system, vaporizations of water in liquid, equilibrium, vapor, gas, less volume, more volume. It is an endothermic process and there is increase in volume. Thus, the favorable conditions for the vaporizations of water are high temperature and low pressure. Solubility of gases in liquids, gas G plus water liquid, equilibrium aqueous solutions L. When a gas dissolve in liquid, this is decrease in volume. Thus, the increase in pressure will favor the dissolutions of gas in liquid. Now, Chatelier's principle: if a system at equilibrium is subjected to a change of any one of the factors, such as the concentrations, pressure, or temperature, then the equilibrium is shifted in such a way as to the effect of changes. Chatelier's principle is applicable for both chemical and physical equilibrium. Chemical equilibrium, effect to change in del Ng is equal to 0, del Ng greater than 0, del Ng is smaller than 0, A equilibrium B, A equilibrium 2B, 2A equilibrium B. Effect of change in del Ng is equal to 0, A equilibrium B, del Ng greater than 0, A equilibrium 2B, del Ng smaller than 0, 2A equilibrium B. Concentrations, A in 1, A increase, forward directions, forward directions, forward directions, forward directions, A decrease, backward directions, and backward directions. Pressure, increase in pressure, unchanged. A equilibrium B, in case of A equilibrium B, unchanged. In case of A equilibrium 2B, backward directions. In case of 2A equilibrium B, forward directions. Decrease in pressure, in case of A equilibrium B, unchanged. In case of A equilibrium 2B, forward directions. In case of 2A equilibrium B, backward directions. Temperature, increase in endothermic, A equilibrium B, forward directions. A equilibrium 2B, forward directions. 2A equilibrium B, forward directions. Increase in exothermic, A equilibrium B, backward directions. A equilibrium 2B, backward directions. 2A equilibrium B, backward directions. Dissociations, increase in unchanged, A equilibrium B, unchanged. A equilibrium 2B, dissociations decrease. 2A equilibrium B, dissociations increase. Increase in volume, A equilibrium B, unchanged. A equilibrium 2B, dissociations increases. 2A equilibrium B, dissociations decreases. Now, mixing of inert gas at constant pressure, A equilibrium B, unchanged. A equilibrium 2B, dissociations increases. 2A equilibrium B, dissociations decreases at constant V. A equilibrium B, unchanged. A equilibrium 2B, unchanged. 2A equilibrium B, unchanged.